Welcome to another teardown video. This time it is a signal generator, MFHF generator, TS G72. I think this is an internal model for maybe this was Storno. I'm a little bit, I can't remember really because I've seen those cases before. They're very big and very heavy, and if you see those, they fit the rubber feet. So they are designed for stacking in a lab. And there isn't much to say about this one. External and some frequencies and stuff. And this looks a little bit like radio amateur frequencies. Maybe we got some crystals, and maybe this is just a crystal oscillator and something like that, minus 10 dB. There's not much to say about this. I will try and power it up and see if it works. On the back side, oh, this is heavy. There's a multi-connector. I think this was banana plugs and old style mains. Yeah, let's see if there's any kaboom. Just connected to the scope. This is off. We power on the mains and nothing happens. There's a sound. Oh, look at that. What is this? That is 70 megahertz, right? 7006. Well, look at that. Ooh. Nothing. Okay, so that is... What is... Oh, now it worked. It took a few... Okay, so there's a loose connection or something. 144.49 la 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 la. That is exactly what it says here. Okay, then what? Ooh, that's not good. Oh, we got the funky frequency. Look at that. Oh, this is a mains, right? Or some, no, it is not, because we're running in microseconds. Ah, look at that. By doing a little bit of massage, we got a nice stable frequency. And this is 10.75. This is 10.7. So what is the 10 point? Okay, there's a little bit of crabbity, and then external goes off. That one is not a magic thing. So there's not a lot of stuff to look at here, really. It can do some frequencies, and that's about it, right? So, teardown time. I kind of like designs where all you have to do is finger screw one little knotty thingy out, and then out comes all the goodies. Isn't that just fantastic? Wow, that is beautiful design. Oh man, this case is insanely heavy. What is all this? This is quality. This is how you build a tanker. Okay, it is not falling apart. Wow, that is one amazing instrument. Different frequencies in boxes and feed through capacitors. Wow, those are absolutely not amateurs, the guys that designed this. Don't you just love it? And this is the power supply, and somebody said okay to this in 70. 52 years ago. This was okayed. And it is still alright. It is still rocking and rolling, and it is really... I think we need to have a little look of what is in there. We got a diode there, the switches. It's ooh. It is very, very heavy. I didn't expect this to be such a surprise. And then all the different frequencies, they come, those three, they come to, what is that, filters, multiplexers, some kind of cool things, right? We need to have a look at that. I'm gonna find a screwdriver. I think it's gonna be itsy bitsy miny mo la la la. So I took out the first one so we could access this, and of course it was Storno. That is, I thought I saw those cases before. So the power dividers, this is a resistive type. And of course we're going to measure what kind of performance they got, but that it could be a cool score as well. So now I got the first one out, but it's nice with BNC connectors, so it's easy to access. I kind of like this case. They didn't really put a lot of screws in this, but okay, it's only 10 megahertz. But the feed-through capacitors here that is a good idea. Let's open and see what we got. So that is it. A crystal, oscillator, amplifier, and then output. Pretty design. This is exactly how it's supposed to be. You don't need any more. A really big case for this. It could easily have been half, even with 1970s components. This could have been half, and all this is steel, about 1 millimeter thick steel. So you can imagine this is quite heavy. I was hoping for some logos or names or anything, but all we see is a number like that. It also looks a little bit like this PCB. Yep, was used for something else and then modified for this product or whatever, the frequency. Let's open the next one, see if it's the same. Oh my god, it is a lot different. So this is the 145 megahertz version, and what do you know? It is full of stuff, and this will be the oscillator and a relay, and my goodness, that is a big surprise. How complicated is this really? What have we got up here? Isn't that just beautiful? Look at that. That is pretty cool. They knew they wanted a resistor like that. Okay, so yeah. So this is the output, and all sorts of matching and stuff. And then the output is, again, here is another attenuator and a little diode and okay, what have you. I don't know. Okay, so there's a little power transistor here. So this is probably the output. So they took half a radio here and plugged it in. This case, this looks a little bit like a Storno radio, right? Yeah, that is pretty cool. So what is inside the last one? And now we are... Yes, we are inside the 77 megahertz version. And it looks a lot like the same. Again. They also did a little bit of tuning and trimming, and again the attenuator here, and yeah. Great, so that was the 3 oscillators. Let's look a little bit more on the power dividers. What can they do? Alright, so this is how it works. The 3 outputs from the 3 oscillators. They're connected to the 3 of the ports, and then the last one to the output of the front. So let's try and open this one and see what we got inside, right? Okay, really? I am a little bit disappointed. That is really it. Yeah. Why would you do it like that when you could have put them into a single point, or you could... This, I bet, is not going to give a broadband performance. But hey, let's measure that, right? And here is the power supply. A really nice unit. Of course, again, specially designed for this case design. And it looks like, yes. So it's, well, this could have been mounted somehow here, and you could just easily unscrew and replace. So that's pretty cool. And the same frame can also be used for dual outputs. Oh, we got a lot of different... Okay, here we go. Oh, that is really nice. Did you see that? All those different voltage ranges. So you can fine tune. This is a very good universal 12 volt. Oh, so you got 2 windings, right? And here they just put them in series. Or, yep, more 12 volt windings. So that is how it works. And again, more 12 volt windings. So 1, 2, 3, 4. Oops, oopsie doopsie. 5, 6. Huh? Are they connected together? That is a little bit confusing. Those are the mains, right? 1 and then la 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 la. But where are some of them? But I can't see the numbers. That is difficult. I don't want to get myself blown up with this. But let's look at the regulator PCB. So we're getting more and more into the power supply. So this is the mains fuse. How do you like this? Okay, let me be a little bit fair and put the PCB exactly. In the... See? Now, how do you like the safety distance here of 1 millimeter to the op-amp case from mains? So that was the good old safety standards of 1970s. I got a few transistors and probably a little sooner. Okay, yeah, no, we could just... Yes, that is exactly what it is, right? And a little fancy-pansy op amp. That is really nice. So that is what this can do. Nothing much to say about it. What is it called? LM301. No, 304. And probably we'll find 69. Wow, so it's from 69. Oi, oi, oi. Really good old stuff. And when... it's not always you can find those date codes. Alright, I think this is just trash, to be honest, but I would like to measure this one. Let's try and measure the power splitter. So I've zeroed. So if I just plug in one, and of course you need a load on the last one. See what happens with the curve. It gets a lot more flat. But look at that. This is from 0 to a gigahertz. I kinda did not expect that. Really? So it's 6 dB. That is exactly what it's supposed to be. Let's go all the way to 6. Or to 1 gigahertz. Really? Okay, we're gonna sweep some bigger. Okay, now we are playing a little bit wider. So this is 3 gigahertz. Okay. Let's try the 2. Oh, there's a little resonance. And let's try and put on the... Okay. It's actually not that bad. So 2 gigahertz for 7. And if we go to 1.5 gigahertz, it's 4. I don't know. But look, it's really not that bad. Okay. What do you know? So what the heck, if you go for the first 1 dB error, you can use this one to about a gigahertz. That is crazy, depending on what input you go to. So this is 7. So let's take the 2 outer and see, it's 5. So that is, of course, there's a little bit of imbalance here, right? But all the way to a gigahertz. That I am sure you did not see coming when you saw the internal parts. I tried to unscrew this little holder for the crystal because I wanted to see if there's a double or anything in here. Then the whole unit just comes up. And look at that. This is aluminium, right? So they got it coated with copper so they can solder on the inside. That is really sexy. It wasn't that difficult to get this out. Here's the little crystal oscillator. So the crystal is 11.68, and this is the 70 megahertz unit. So what we see here will be multipliers coming in here, and then they're doing multi filtering and output powering. The output power transistors here, and look at that. The heat sink Goes with a little screw here. I can't remember I have seen anything like this before. That one is really cute. And then there is a ceramic isolation disc, and then a little plastic rubber washer, and then they just made the hole in this metal big enough for the screw not to touch. And this is copper, full of grease. Ugh. So this was touching the outer wall. But it amazes me a little bit why they needed this big power transistor to generate minus 10 dBm. And then all those attenuators to get down. That is a little bit stupid.